In this video, we'll be continuing our trends theme. This one will be on ionic radii. So ionic radii is very similar to atomic radii. That was the last video, except ionic radii, as you can figure out, is related to ions. Ionic means ion. So a little bit of review before we start. An ion is an atom that has a charge. So that means the protons and electrons are not equal. You could have more protons or more electrons. They just can't have the same number. If you have the same number, the charge will be neutral, zero charge. The word ionization is the process that results in the formation of an ion. So anything that results in electron changes. So if there's a process that strips an electron from the atom, we'd say that that atom has been ionized. That would be an ionization process, removing the electron. A cation is a positive ion. So ion up here, hold on, let me get my marker. Ion is anything that has a charge. A cation is specifically something that has a positive charge. In order to become positive, you have to lose electrons. So the number of protons will be greater than the number of electrons. And an anion is a negative ion. Negative. So in order to become negative, you have to gain electrons, have more electrons than protons. So more electrons, negative, more protons, positive. So there's three rules for determining the size of ions. The first one has to do with cations. What you need to know is that the removal of an electron will always make the size of that atom smaller. Losing electrons will make the size smaller, the radius. So if I look at these two examples, or these two ions, they're both cations. This has a +1 charge, so it has lost 1 electron. This is a +2, so it has lost 2 electrons. Well, the rule is if you remove an electron, the size will decrease. So if I had sodium that was neutral, and I lost 1 electron, that would make this smaller than this. Well, losing another one is going to make it even smaller. So if I asked you which one is bigger between these two, it's going to be this one. They both lost electrons, but this one has lost more, so it will be even smaller. The opposite rule has to do with anions. So if you add an electron, that will make the size increase. So here's our example. We've got sodium. This has gained 1 electron. This has gained 2 electrons. And again, let's go back to the example. If I have a neutral sodium and it gains 1 electron, this will be bigger than this. Because you're adding another electron. Electrons repel, so they're going to spread out a little bit more, making the atom bigger. Adding a second electron will make it even bigger, so this is the biggest of the three here. But I was only asking about these two, still the biggest. Now, if you have different elements, so the examples we just covered were if you have the same element, one is just gained or lost more than the other. Those are pretty easy to follow. More electrons, bigger, less electrons, smaller. Now, this gets a little bit trickier. We have to talk about isoelectric atoms. So an isoelectric atom is an ion with the same number of electrons as a different atom or ion. Basically, isoelectric means same number of electrons, but different number of protons. So it's almost like isotope, same number of protons, different number of neutrons, but this one's dealing with electrons now. So you have maybe two different atoms, but they have the same number of electrons. They would be called isoelectric to each other. So an example is aluminum +3 and neon. They're different elements, but they do have the same number of electrons. So if I look at aluminum, aluminum is number 13 on the periodic table, neon is number 10. That means that it has 13 protons for aluminum, 10 for neon. Now because this is neutral, so let's put 10p, 13p. Because this is neutral, it also has 10 electrons. Aluminum's not neutral. It has a +3 charge. That means it's lost 3 electrons. Normally, aluminum, when it's neutral, would have 13 electrons, 13 protons. But it has lost 3, so it only has 10 electrons. So that's what we mean by isoelectric. They both have 10 electrons, so their electron clouds look the same. Now, the rules for determining which ones are bigger will be coming up next. I just wanted to give you an example of what isoelectric means. So case number 1, the isoelectric atoms are different. You use the normal radii rule. So here's the normal atomic radii rule. So case number 1, we've got sodium plus 1 and chlorine minus 1. So we've got sodium over here. It's got 11 protons, 11 electrons if it were neutral, but it's not. It's got a plus 1 charge. That means it has lost an electron. So if it had 11, it's actually like neon. So sodium, what you got to figure out is that this sodium plus 1 is isoelectric to neon. It has the same number of electrons as a neutral neon atom. Chlorine minus 1 means it's gained an electron. So chlorine's normally here, but it's gained an electron, so now it looks like argon in terms of its electron configuration. So sodium, isoelectric to neon, chlorine minus 1, isoelectric to argon. Now what you do is you apply the normal atomic radii rules to these. Which one would be bigger, neon or argon? I look over here, argon's further down, so this must be the bigger one. And that's how you solve these. If they have different isoelectrics, follow the normal rules. Chlorine minus 1 has a lot more electrons than neon plus 1, so it makes sense that it is the larger atom. Now case number 2, if the isoelectric atoms are the same, use the number of protons versus electrons, and the lower protons is always bigger. So that's a mouthful. So let's do an example here. Chlorine minus 1, we've actually already done this one. It's just like argon. I'll actually erase this. So chlorine minus 1 is just like argon. Ca plus 2. Calcium is 20, number 20. It's hard to see that. But it's lost 2 electrons, so we go backwards 2. It's also just like argon. Normally calcium has 20 electrons, but it's lost 2, so now it's 18 like argon. Maybe have your periodic table out for this so that you can actually see the periodic table that I'm pointing at. Now they're the same. So this is where it gets tricky. Well, which one's bigger? We can't follow the normal rule because they both land on argon. We can't do what we did up here. So what you do is you go back, okay, both of them have the same number of electrons, so the one that's going to be smaller is the one with more protons. So calcium has 20 protons, so 20p for protons. Chlorine has 17 protons. So you got to imagine that the 20 protons are going to be pulling the 18 electrons that it has. It's going to be pulling those in closer, making this one smaller. So this one is not the bigger one. The 17 protons isn't going to be pulling those 18 electrons in quite as tight. So it's going to be left a little bit bigger. The electrons will be able to expand out a little more. So to summarize that, chlorine minus 1 has the same number of electrons as calcium plus 2. So we go back, after we find out that they're both isoelectric to argon, we go back to the original element. Whichever one has less protons is going to be the bigger one. So let's do some examples together. Let's just start the first rule here. Let's find our rule number 1. See if I have any of those. Perfect. Here's rule number 1. They're both cations. This one has lost 2 electrons. This one has lost 4. So this one's going to be smaller because it has less electrons. This is going to be bigger. Let's go to rule number 2. We've got anions here. This is neutral, this one. This is gain 3 electrons. In order to fit 3 more electrons, you're going to need more space. It will make that atom bigger. Let's look at the last 2 rules here. Let's just pick this one. Not exactly sure which rule this will land on, but it's the last rule. It's a matter of which case it is. So look at sodium plus 1. Sodium plus 1. Plus 1 means I go backwards because it lost electrons. That's a key thing to understand there. Plus 1 means it only has 10 electrons. So this is isoelectric to neon. Sulfur minus 2 has gained 2 electrons, so it's like argon. Okay, in this case they are different, so I follow the normal rules. Argon would be bigger. Okay, let's look at this one. This will be our last rule that we haven't covered yet. Barium plus 1. Sorry, that should be, I believe, barium plus 2. If it's not on your note outlines, let's just go ahead and change that because I think it'll be better that way. So let's change that to barium plus 2. Barium plus 2 would be like xenon, Xe. Iodine minus 1 would also be like xenon. I'm guessing your note outline has a plus 2 there, so we'll go with that. Okay, you have the same isoelectric atom. So now you look at barium. Barium has 56 protons. And iodine, I go back and look, iodine has 53. So I take whichever one has less protons. If their isoelectrics are the same, this has less protons, so it's bigger. Okay, so pause the video, give the rest a shot on your own. Okay, now let's come back. Let's see how you did. If I were looking at the top two, this one has lost less. We did the next two already. Cesium plus 1 looks just like xenon. Iodine minus 1 is also like xenon. This one has less protons, so I'd go that one. Titanium plus 2, I go backwards. That is like calcium. Mn plus 2 is like vanadium. They're different. Calcium and vanadium are different, so I apply the normal rules to these. Calcium is further to the left, so this is bigger, so I'd circle this one. Bromine plus 1 and bromine minus 1. This is lost an electron, this is gained an electron. More electrons is bigger. They're the same elements, more electron is bigger. Selenium minus 2 would be like krypton. Bromine minus 1 would also be like krypton. Okay, same isoelectrics. Selenium has 34 protons. Bromine has 35. Less protons is bigger. So there we go. There are your answers. Let me know if you have any questions.